All right, welcome everyone. If you're prepping for government exams, you've probably seen machine learning pop up. And let's be honest, it can seem a little intimidating. Well, in this explainer, we're going to break it all down, make it super clear, simple, and memorable, so you'll have these concepts locked in when exam day comes around.
So, here's our game plan. We're going to start with the basics. What exactly is machine learning? Then we'll pop the hood and see how machines actually learn stuff. After that, we'll explore the different ways they do it, and finally, we'll boil it all down to the key takeaways you really need to know.
You know, this question right here, it's literally the heart of what machine learning is all about. Think about it. We're not just feeding a computer a long list of if-then commands. We're somehow giving it the power to figure things out on its own, to adapt and get better. So how on earth does that actually happen? Let's dive in. Okay, so first things first, let's really get a handle on the core idea of what we're talking about. The best way to think about it is like this. Artificial intelligence, or AI, is the big, broad dream of making machines smart. Machine learning is one of the main ways we're making that dream a reality. Instead of us coding every single rule, we just give the machine a whole lot of data and say, here, you figure it out. It's a lot like how we learn, from experience, by spotting patterns, making mistakes, and then getting better next time. And what's so wild is that this isn't some brand new idea. I mean, look at this timeline. People were thinking about this stuff way back in the 1950s. That moment in '97 when a computer beat the world chess champion, that was a huge wake-up call. But it's really since 2012, with the explosion of deep learning, that this technology has gone from a lab experiment to being everywhere, powering the stuff you use every single day. So that's the backstory. But how does this actually work? How does a machine go from looking at a mountain of raw data to making a genuinely smart prediction? Well, it turns out it's a pretty logical step-by-step journey. It's a really methodical process. You start by collecting a ton of historical data. That's like the study material. Then you clean it up and let the machine train on it, letting the algorithm find patterns and build its own set of rules. After that comes the test. You see how accurate it is with new data it's never seen before. If it passes, you deploy it out into the real world to start making actual predictions. And this is absolutely key, especially for your exams. Understanding the difference between training data and testing data. The training data is the textbook. It's what the machine studies to learn. The testing data, that's the final exam. It's completely new information. A model isn't any good if it just memorized the textbook. It has to prove it can solve new problems it's never encountered before. Okay, this next part is a really big deal. Machine learning isn't just one single thing. It's more like a toolkit with different approaches for different problems. And for your exam, knowing the difference between these three main types is pretty much non-negotiable. So first up, supervised learning. The easy way to remember this? The data comes with an answer key. It's labeled. We show the machine an input, like a picture of an animal, and we also tell it the correct output. That's a cat. The machine's job is to learn the connection. It really is like having a teacher guiding you. And within supervised learning, you've basically got two main jobs it can do. First, there's classification, which is all about sorting things into groups or categories. Is this email spam or not spam? Does a student pass or fail? Then you have regression, which is about predicting a specific number, like the price of a house or tomorrow's temperature.
All right, now let's flip that idea on its head. With unsupervised learning, we take away the teacher and the answer key. The data is unlabeled. We just dump a whole bunch of information in front of the machine, and its job is to find the hidden patterns all by itself. Imagine giving someone a massive box of Legos and just asking them to sort them into logical piles.
So what's it trying to do? Well, two big things. First, there's clustering. That's where it groups similar things together, like finding different types of customers based on what they buy. And then there's association, which is about finding rules, like how a supermarket realized that people who buy diapers often buy beer too. And that brings us to our third and final type, reinforcement learning. This one is all about learning by doing, through trial and error. Think of an AI learning to play a game. Every time it makes a good move, it gets a reward, points. Every time it makes a bad move, it gets a penalty. After playing millions of times, it learns the best strategy to get the highest score possible, all on its own. All right, we've covered the big three. Now let's do something that's super helpful for revision. Let's put them all side by side. A direct comparison like this is probably the best way to make these ideas stick in your head. Seriously, this table is your best friend for the exam. Just look at the breakdown. Supervised learning, it uses labeled data, like having a teacher. Its goal is prediction.
Unsupervised, it uses unlabeled data, like learning by just observing, to find hidden patterns. And reinforcement, that's learning by trial and error in an environment to figure out the best action. The examples make it all crystal clear.
Okay, let's bring it all home. For our last section, we're going to talk about the key takeaways, the pros and cons you'll definitely want to have in your back pocket, because these kinds of evaluation questions pop up all the time. So, what are the upsides? Well, they're huge. First, machine learning can chew through enormous data sets that a human team could never get through. It automates decisions, it gets smarter the more data you give it, and it can find subtle trends and patterns that are basically invisible to the human eye. But of course, it's not all perfect. There are some really big challenges. These models need a ton of good quality data to work well. Building them is expensive and can take a long time. And this is a big one. If your data's biased, your model will be biased too. That leads to the black box problem, where sometimes we can't even explain why it made the decision it did. And we're going to end on this quote from the guy who started it all, Arthur Samuel, back in 1959. It really just brings everything back to that one simple, powerful idea: giving computers the ability to learn without us telling them exactly what to do. That's what sparked this whole revolution. And the question we're all still asking today is, what will we empower them to learn next?